In 1983, the smartest physicist alive sat down for an interview with the BBC. The bloke had a Nobel Prize. He'd helped build the atomic bomb. He'd cracked quantum electrodynamics, the most accurately tested theory in human history. And then the interviewer, a man called Christopher Sykes, asked him a question a 6-year-old could ask. What does it feel like between two magnets? Why do they push each other? Simple, innocent. The kind of question you'd ask while sticking a fridge magnet to a tin of baked beans. And Richard Feynman, the smartest physicist alive, refused to answer it. Not because he didn't know, because he knew something almost nobody talks about. He knew that the question itself was a trap. And 40 years later, modern physics is still stuck in the same trap. So today, we're going to walk straight into it. G'day, you're watching Curious Physics AU, and let's get into it. If you've never seen this interview, find it after this video. Feynman sits there in a navy jumper, hands moving like he's conducting an orchestra, and he gets a bit cranky. Not at the interviewer, at the question. He says, and I'm paraphrasing, "I can't explain magnetic force in terms of anything else you're familiar with, because I don't know anything you're more familiar with." And he keeps going. He talks for nearly 7 minutes about why questions are dangerous. Most people watching at the time probably thought he was being difficult. He wasn't. He was being more honest than scientists are usually allowed to be on camera. So let's break down what he actually meant, because once you see it, you can't unsee it. When someone asks you to explain something, what they really mean is, take this thing I don't understand and connect it to something I already do understand. Why does ice float? Because it's less dense than water. You already know what density is, so the explanation clicks. Why does a kettle whistle? Because the steam pressure builds up and forces air through a narrow hole. Already familiar. Done. But now try this one. Why does one magnet push another magnet across thin air without touching, with nothing visible between them? What are you going to reduce that to? You can't say, oh, it's like how a rubber band stretches, because rubber bands are made of atoms, and atoms are held together by electromagnetic force, which is the magnet. You can't say it's like wind pushing a sail, because wind is moving molecules pushing against other molecules, and that pushing is also electromagnetic. You'd be explaining magnets using magnets in disguise. There is no more basic thing to point to. You've hit the bedrock. And here's where it gets weird. What we do know about magnets is genuinely beautiful. Every electron in the universe is, in a sense, a tiny spinning charge. And spinning charges create magnetic fields. In most materials, wood, glass, your phone case, the electrons spin in random directions. And all those tiny fields cancel out. So the material isn't magnetic. But in a handful of metals, iron, nickel, cobalt, the electrons can lock into formation. Billions of them, all spinning the same way, like a stadium crowd doing the wave perfectly. When that happens, the material becomes a magnet. That's it. That's the secret of a fridge magnet. Now, we can describe this with mind-bending precision. Maxwell's equations from the 1860s still hold up today. We can build MRI machines that map the inside of your skull. We can build maglev trains that float above the rails at over 500 k's an hour. Every hard drive ever built runs on this. The maths works to 10, 12 decimal places. But, and this is Feynman's whole point, that's description, not explanation. Now, here's the part that genuinely messes with me. Two magnets push each other across a gap of empty space. Nothing touches. Nothing visible passes between them. So how does one magnet know the other is there? Back in Newton's day, this was called action at a distance, and it freaked Newton himself out. He wrote that the idea of one object affecting another across empty space, with no medium between them, was so absurd that no person with a working mind could believe it. Newton, the bloke who invented gravity equations. Even he thought it was nonsense. And yet, here we are, nearly 400 years later, still watching magnets do exactly that on the back of every Australian Geographic sticker stuck to a Toyota in a Bunnings car park. So what's the modern answer? It's this. The space between two magnets is not empty. There's a thing called the electromagnetic field, and it fills the universe. Every cubic millimetre, including the air in your bedroom, the vacuum of space, the inside of your bones. The field is real as a chair. And it's not still, it's buzzing. Quantum mechanics tells us that the field is constantly producing what physicists call virtual photons, tiny, fleeting particles of light that pop into existence, carry force from one charged object to another, and vanish before you can measure them directly. When two magnets feel each other across a gap, they're swapping virtual photons at a furious rate. That's what the force actually is. This is quantum electrodynamics, or QED, and it is the most accurately tested theory ever produced by humans. We've checked predictions of QED against experiments and matched them to 14 decimal places. That's like measuring the distance from Sydney to Perth and getting it right to within the width of a single human hair. Think about that for a sec. Every time you see a rainbow, every time your phone gets reception out in the bush, every time the sun warms your face on Bondi Beach, every nerve signal firing inside your brain right now as you process this sentence, that is electromagnetism doing its thing. It is not a niche topic. It is most of what you experience as reality. And yet, and here's the punchline, the man who built that theory, the man who won the Nobel Prize for it, was the same man telling that BBC interviewer that we cannot explain magnets. Feynman wasn't being modest. He wasn't dodging. He was making a razor-sharp distinction that most science teachers, most pop science books, and frankly most YouTube videos completely smudge over. We can describe magnets in stunning detail. We cannot explain them in terms of anything more familiar, because there isn't anything more familiar. Electromagnetism is one of the four fundamental forces: gravity, electromagnetism, the strong nuclear force, the weak nuclear force. And at the bottom level, they don't reduce to anything else. They just are. And here's the bit that absolutely sends me. There's a number in physics. It pops up everywhere electromagnetism shows up. It's roughly 1 over 137. Physicists call it the fine structure constant, and it controls how strongly electrons grip onto photons, basically how strong electromagnetism actually is in our universe. Feynman called it, and I'm quoting him almost directly, one of the greatest damn mysteries of physics, a magic number that comes to us with no understanding. We don't know where it comes from. We can't derive it from anything deeper. We just measure it, plug it in, and the universe runs. If that number was a little bigger, atoms wouldn't form. A little smaller, stars wouldn't burn. We're alive in a narrow band where it works. And nobody, not Feynman, not Einstein, not the smartest physicists working at CERN or at the ANU today, can tell you why. Which leads us to the question modern physics genuinely cannot answer. Why does electromagnetism exist at all? Why does the electron carry the exact charge it does? Not a tiny bit more, not a tiny bit less. Why are photons massless? Why is the universe built on these particular four forces, with these particular numbers locked in? If you ran the maths with slightly different numbers, and physicists have done this, you get a universe with no atoms, no chemistry, no stars, no fridge magnets, no curious physics AU, no anything. Run the dials a bit differently, and the cosmos collapses into nothing, or expands into a thin grey soup. The fact that we live in a universe where iron filings line up around a bar magnet, where you can stick a note to the fridge with a tiny piece of metal, that fact is a coincidence so sharp it makes physicists nervous. We have no idea why the dials are set where they are. Some say it's a multiverse, where every possible setting exists somewhere. Some say there's a deeper theory we haven't found yet. Some say it's just brute fact. No reason, deal with it. And nobody can prove which is right. So Feynman, sitting in that navy jumper in 1983, wasn't being awkward. He was telling the truth in public, which is harder than it sounds. He'd spent his life describing electromagnetism better than anyone alive. And he wanted you to know that description and explanation are not the same thing, and that the gap between them is where real physics actually lives. 40 years on, that gap hasn't closed. We've built better instruments, better theories, better predictions. The standard model is breathtaking. The maths is sharper than ever. But the why at the bottom of a fridge magnet is still wide open, still unexplained, still waiting for someone, maybe someone watching this video right now, to crack it. So next time you stick a shopping list to the fridge with a magnet shaped like a koala, just take half a second to clock what's actually happening. You're holding a piece of the universe nobody has ever truly understood. The smartest physicist of the 20th century said so on camera. And modern physics, for all its brilliance, still hasn't argued back. If this rewired your brain a little, hit that like button. It genuinely helps the channel reach more curious people. Subscribe if you want more videos that take a tiny everyday thing and crack it open. And drop a comment below. What's a simple thing in physics that secretly does your head in? Could be lifts, could be rainbows, could be why ice cubes crack in a glass of water. I read every single comment, and your suggestion might be the next video. Catch you in the next one.